This is chapter 6. Chapter 6, section 3, problem 17. Here. A researcher wishes to estimate with 95% confidence population proportion of adults who think Congress is doing a good or excellent job. The estimate must be accurate within 1% of the true proportion. No preliminary estimate is available. Okay. So here you can see the confidence interval here. Confidence level here, and they want for 95. So the rejection region will be two tails on each side. So half of 5% will be on one side, half of 5% will be on the other side. So the z-scores correspond to the z of half that rejection area is going to be 1.96. So 1.96 on one side and a negative 1.96 on the other. So I plug in here. Okay, so I have my P. Now this is assuming that no preliminary estimates available, so we don't know anything about sample population there. So we'll set it equal to 0.5, 5, and 5 here, 50%. And then I have here Z is 1.96 over 0.1, which is my error. And I multiply these out, and that gives me 9604 here, which is the answer there. Then if we know something about a particular sample, to put in my P to be 26 and the Q to be 74. Okay. And the z-score here is 196 and divided by the error. In this case, it's 0.01. And multiply it out, and I get this one here. And it just rounds to the nearest whole number. Okay. That's how you go about doing this problem. You can check it by going to StatCrunch. Go to stats, proportion, unsample. This is width. In this case, the width here corresponds to the error. When we put that error in, we put it in, put twice, the 1% is the error. We put twice that, so we would have something like 0.02. The confidence level is 95. And for A, we don't know the target proportion, so I put in 0.5 there. And we click on this, and it gives us a sample size of 9604, which is right there when it checks. And for the other one, we know something about the target proportion here. So my target proportion, we know something about that one. I'll put in 0.26. Let me click here. It gives me 7391. And then up here, so it accepts that too, 7391. Okay. That's just a thought. You can have a small sample and get the same meaningful results, or spend more money and use a larger sample and get the same meaningful result.